we present Query NLT, context-aware integration of language and visual references for natural language tracking. Tracking by natural language specification aims to consistently localize a target in a video sequence, given a linguistic description in the initial frame. Previous approaches initially localize the target object solely based on the given language description, and the grounded target serves as the visual template to establish correspondence with the search image. The final results are derived through the amalgamation of the outcomes. These approaches typically process the language and template independently until merging their matching results, which may lead to ambiguity in target identification. As illustrated in Figure A, due to the target's movement, the initially provided language description, white bird on the left, may no longer align with the current state of the target. This misalignment confuses the tracker's judgment of whether to focus on white bird or on the left during the matching process. What is more, occlusions of objects may bring background clutters into the template. As shown in Figure B, a small yellow bird is contained in the template, which may further interfere with the identification of the target white bird. The late fusion at the resultant level makes it difficult for the tracker to discern which candidate object is the real target, thus leading to tracking. We observe that the language description and the visual template are complementary, and combining these two for matching contributes to a comprehensive understanding and perception of the target. As illustrated in Figure C, the historical results embed the target's motion information, which helps filter out status descriptions that fail to align with the actual target in the language expression. For instance, on the left, referring to a small yellow bird rather than the true target should be removed. Simultaneously, the categorization of the target serves as a reliable cue for filtering out extraneous background features in the visual template. Specifically, patches belonging to white bird are assigned high attention weights, and patches belonging to the yellow bird and background are masked. The revised language description collaborates with the accurate visual template to help point to the true target in the challenging. To the end, we propose Query NLT depicted as follows. During the tracking phase, we collect the appearance feature and positional feature of the target based on the historical localization results of the target and store in a template memory as the dynamic visual reference. Given a search image and a language description, we first employ a feature extraction module to obtain the search feature and language feature, respectively. Subsequently, we utilize a prompt modulation module to filter out the inconsistent description in the initial verbal reference and the visual reference, thus forming more precise prompt information to guide the target location. Finally, a target decoding module is responsible for jointly establishing the correspondence between the multimodal references with the search image in a one-step. We introduce our proposed multimodal prompt modulation module in detail. Specifically, the template memory stores the object position information of multiple previous frames, serving as a motion cue to assess whether the state description in the text feature aligns with the current scene. Meanwhile, it contains the object appearance information acting as a visual cue to evaluate whether the target appearance description in the text feature is correct. We utilize a multi-head cross-attention operation to generate the language prompt, and the purpose of appearance modulation is to generate a binarized mask based on the category or appearance description of the tracked object in the sentence, which can better fit the shape of the prompt modulation, along with the target decoder module, forms a unified framework to utilize the verbal and visual reference for natural language tracking. By forming context-aware query information, we compare our approach with state-of-the-art trackers, including Joint NLT, TNL2K, and others approaches, on 3 challenging natural language tracking datasets. The result emphasizes the effectiveness of dynamic and context-aware linguistic descriptions for improving tracking performance. Qualitative results are also. Thank you for